Hello dear students, Assalamu alaikum. So today we're going to solve some questions related to Maths D or General Maths Geometry, circle theorem problems. So first question, this question is taken from Winter 2018, variant 1-2, question number 18. So look at the question in the diagram, A, B, C, D, E, all these points are lying on the circle, on the circumference of the circle. AB is parallel to CD. It is already given. These two lines are parallel. Some of the angles are given and some of the angles are unknown. We have to find those angles. So first, question A, we need to find out the value of X. Now look at the quadrilateral BCDE. So this is a cyclic quadrilateral BCDE. Cyclic quadrilateral. What is cyclic quadrilateral? If the four vertices of a quadrilateral lie on the circumference of a circle, this is a cyclic quadrilateral. Look here, point B, point C, point D, point E, all of them are lying on the circumference of a circle, so that's why it's a cyclic quadrilateral. And a cyclic quadrilateral, sum of the opposite angles will be always 180 degrees. Sum of the opposite angles will always be 180 degrees. So if this is 127, if you add this X and 127, that has to be 180 degrees in total. So that means X plus 127 equals to 180 degrees. And as this is Maths D paper 1, you cannot use the calculator. So the value of X is going to be 180 minus 27. You have to solve the maths mentally. You cannot use the calculator. So the value of X is 53. And you don't have to write down these things. This is just 1 mark. So straight away you can write down the answer. I'm writing down here so that you can understand. Otherwise, in exam paper, if the question is containing only 1 mark, you don't have to explain or you don't have to show the calculation. You can straight away write down the answer. And if you show the calculation, that's not a problem. But it's not mandatory to show the calculation. You just straight away you can write down the answers if the question is having only 1 mark. Then we have to find out why. Now, look at here. So standing on the same arc BC, angle at the circumference is Y. So standing on the same arc, angle at the circumference at other point is 40 degrees. So when two angles, they're standing on the same arc, when two angles, they're standing on the same arc, they're supposed to be equal. So that means Y equals to 40 degrees because they're standing on the same arc BC. Next question C, we have to find out the value of set. Now how we can find it out? AB and CD, it's parallel. And BE is the intersector. AB and DE, both the sides are parallel. And BE is the intersector. So interior opposite angle, they're supposed to be equal, which is also called alternate angle. So in question C, angle ABE equals to angle BED. These are interior opposite angle or alternate angle. So that means 62 equals to 40 plus set. So set equals to 62 minus 4. That's 22. Okay, fine. Let's move on to the next question. I've taken this question from summer 2018, variant 1-2, question number 22. Here in the diagram, you can see that ABCD, all these 4 points are on the circle. And we can also see that two tangent, AT and BT. What is tangent? Tangent is a straight line which just touches a single point of a circle, single point of a circumference of a circle. So you can see that AT line is touching the circle at point A and BT line is touching the circle at point B. So AT and BT, both of them are tangents. And some of the angles are given and some of the angles are also unknown. We have to find those values. So first we need to find out the value of x. So standing on the same arc, question A, standing on the same arc, angle at the center will be double to the angle at the circumference. Standing on the same arc BCD, standing on the same arc BCD, angle at the center will be always double to the angle at the circumference. So that means in question A, x is going to be 53 into 2, 106. Then we have to find out the value of y. Now, quadrilateral ABCD is a cyclic quadrilateral. Quadrilateral ABCD is a cyclic quadrilateral. In cyclic quadrilateral, sum of the opposite angles is always 180 degree. Sum of the opposite angles is 180 degree. I have discussed in previous maths what is a cyclic quadrilateral. So sum of the opposite angle, that means we can write down A plus C, 53 plus Y equals to 180 degrees. So Y equals to 180 minus 53. 127 degree. Then we need to find out the value of Z in question C. So for solving question C, you need to know a theory. And what is that? From outside of a from a single point outside of a circle, if you draw two tangents. From a point outside of the circle, if you draw two tangents, the length of both the tangents are going to be equal. If you draw two tangents from a point outside of the circle, the length of the two tangents is going to be equal. So triangle ATB or ABT, that's an isosceles triangle. In isosceles triangle, two angles will be equal, or angles opposite to equal sides are equal. So these are equal sides. So if this is said, it's going to be said as well. So we can write down. Set plus 62 equals to 180 degree. So Z equals to 180 minus 62 divided by 59 degree. Next, we have to find out T. Now, you need to know about another theory. When the radius intersects the tangent, then the angle at that intersecting point is going to be 90 degree. When the radius of a circle intersects tangent, then the angle at that intersecting point is going to be 90 degree. So for solving D, you can write down T plus Z equals to 90 degree. Now we know the value of Z, which is 59. So T will be 90 minus 59. So 31 degree. Because OB is perpendicular to BT. OB is perpendicular to BT. So sum of T and Z is going to be 90 degree. And as we know the value of Z as 59 that we have found out in the previous question, so easily you can find out the value of T. Okay, fine. Let's move on to the next question. This question is taken from summer 2018. Variant 1-1, question 8. Now, A, B, and C are points on the circumference of a circle. Center O is the midpoint of BC. ABC is 38 degree. Tangents are drawn from T to touch the circle at A and B. At first, we need to find out the angle BCA. Now, look at triangle ABC. This is the diameter. Diameter always makes 90 degree at the circumference. Diameter will always make 90 degree angle at the circumference. So say for example, this will be always 90. This will be always 90 degree. Okay. So in triangle ABC, 90 degree plus 38 plus ACB equals to 180 degree. So 52 degree. Next, we need to find out angle ATB. Now again, there are two tangents TA and TB. They're supposed to be equal. So right, so angle ABT, triangle ABT is an isosceles triangle. So as this is an isosceles triangle, how we can find it out? Now here, this angle is 90 degree. Why? Because BT is the tangent and BC is the diameter. So I've said in the previous question, I've explained that tangent and radius are always going to make 90 degree. I mean, at the intersecting point of the tangent and the radius, a 90 degree angle will be formed. At the intersecting point of the tangent and the radius, an angle of 90 degree will always be formed. All right. So from here, angle TBA plus 38 will be equals to 90 degree. So TBA 90 minus 38. 52 degree. Now, if this is 52 degree, this will be 52 degree as well, because isosceles triangle, these are equal to sides, so angle opposite to equal sides are equal. So angle T is going to be 180 minus 52 plus 50. So 76 degree. All right. So this is 76 degree. Angle ATB. Okay, fine. Let's move on to question 36. This question is taken from summer 2017. Variant 1-2, question 17. Variant 1-2, question 17. So first question, all the description is in the question, so you can read it by your own. Let's solve the question. A, complete the following statement with a geometrical reason. Angle PTQ equals to 35. So here, angle PTQ and angle PSQ, they're standing on the same arc. They're standing on the same arc. So what you can write? PTQ equals to 35. Why? Because angle PTQ and angle PSQ are standing on the same arc PQ. Next question, B. In B, we have to find out PQT. We have to find out PQT. So this was 35. Now consider triangle PQT. Now, diameter will always make 90-degree angle at the circumference. Diagram will always make 90-degree angle at the circumference. So we need to find out PQT. So what we can write, 35 plus this is 90-degree plus this is PQT equals to 180 degree. From here we will make PQT as the subject. Okay, fine. Next question, C. We have to find out SPQ. In question C, SPQ. Now look at here, this is 35, this is 125, so this angle 180 minus 35 plus 125. That's 20 degree. And diameter TQ always subtends 90 degree at the circumference. 90 degree at the circumference. So SPQ. So SPQ will be 90 minus 20 degree. So that's 70 degree. Okay, fine. Next question, D, SRQ. Now, if you want to find out SRQ, look at here. This was 70 degree. This was 70 degree. This is a cyclic quadrilateral. This is a cyclic quadrilateral. This is 70 degree. So SRQ is going to be 180 minus 70. 110 degree. Okay, fine. So we are done here. Question 34 is taken from 2016. 1-1 winter, and this is question number 7. At first, we need to find out all the informations are given. CDA. CDA. Now, that's easy. Look at here. The diameter is AD. Diameter is AD, so it will subtend 90 degree at the circumference. So the angle ACD is going to be 90 degree, and we need to find out CDA. We need to find out CDA. So 33 plus 70, oh sorry, not 70, 90. 90 plus angle CDA equals to 180 degree. So 57 degree. Then we have to find out angle DEC. DEC. Now standing on the same arc, angle at the circumference is 33 degree. Angle at the circumference is 33 degree. So angle at the circumference here will be 33 degree as well. So B equals to angle DEC equals to 33 degree. So standing on the same arc CD, angle at the circumference here is 33 degree. So here it will also be 33 degree. Okay, fine. Next, we have to find out angle ABC. Now, we already know angle CDA, which we have found out in the first question. Okay, and that was CDA was 57 degree. Now, if we subtract that 57 from 180, because ABCD is a cyclic quadrilateral. ABCD is a cyclic quadrilateral. So the sum of the opposite angle is supposed to be 180 degree. Sum of the opposite angle is supposed to be 180 degrees. So angle ABC plus 57 is supposed to be 180 degree. Angle ABC plus 57 is supposed to be 180 degree. So from here, angle ABC 180 minus 57, so 3 to 123. Because ABCD is a cyclic quadrilateral, and as I have said earlier, that sum of the opposite angles in a cyclic quadrilateral is 180 degree. Next, we have to find out reflex angle EOA. Reflex angle EOA. We know that reflex angles are angles which are greater than 180 degrees. So EOA means we have to find out this angle. We have to find out this angle. Now, how we can find it out? So in question D, on the same arc AE, angle at the circumference is 70 degree. Angle at the circumference is 70 degrees. So angle at the center will be 70 into 2, 140 degree. Angle at the center will be 70 into 2, 140. So if the angle at the center is 140 degree, then reflex AOE will be 360 minus 140. So reflex AOE will be 360 minus 140. So that's 220. Okay, fine. So that's all for this particular video. This will be the part 1 of circle theorem videos, and very soon you will get part 2, where I'll discuss some more maths related to circle theorem. Thank you very much for that. Question 35 is taken from 2016 winter variant 1-2 question number 7. So at first we need to find out the value of x. Now look at here, on the same arc BD, angle at the center is x. Angle at the center is x, and angle at the circumference is 34. And angle at the circumference is 34. So standing on the same arc BD, angle at the center which is x, is supposed to be double to the angle at the circumference. So that means 2 into 34. So x equals to 68 degrees. Then we have to find out the value of y. For finding out the value of y, look at here, ABCD is a cyclic quadrilateral. And I have explained what is cyclic quadrilateral in the previous question. The first question in this video. So, but I'm repeating again, cyclic quadrilateral, when all the 4 vertices of a quadrilateral will stay on the circumference of the circle, that is called the cyclic quadrilateral. And in case of cyclic quadrilateral, sum of the opposite angles is going to be always 180 degrees. So angle C and angle BAD, angle C that means angle Y, and angle BAD that means angle 34, they're opposite. So that means sum of those 2 angles is going to be 180 degrees. So y plus 34 equals to 180 degrees. So y equals to 180 minus 34. So 146. Question C. Find the value of z. Okay, that's also easy. Standing on the same arc BT, angle at the circumference is z, and angle at the circumference is 34. Look at those 2 angles. The z angle and 34 degree, both of them are standing on the same arc BD. So both of them are supposed to be equal. So that means z equals to 34, because both of them are standing on the same arc. Then we have to find out t. Now the diameter BE is subtending the angle BAE. The diameter BD is subtending the angle BAE. So that means that angle BAE is supposed to be 90 degrees, because diameter always subtends 90 degrees at the circumference. Diameter always subtends 90 degrees at the circumference. So that means 34 plus t will be 90 degrees. So t equals to 90 minus 34. 56 degrees. Okay, fine. Let's move on to the next question.